1 second. Chapter 5 is changes. Chapter 5 is solid, liquid, and gas only.
Yes.
So we've completed that lesson.
Can we go over it one last time because my exam is tomorrow?
Okay. So have your school given you any practice paper or any practice questions that might come in the exam?
The teacher has uploaded a slideshow so we can see that.
Did you share it with the team?
No.
See, Vivan, whatever material you are receiving from your school, okay, just share it with the team. Okay, from next time onwards, please make sure that you are sharing it with the team.
Okay, ma'am.
Okay, just a minute. I'll just open your specification. So we discussed the interconversion of states of matter and everything, right? Then you also have in your syllabus the ideal gas molecules. So in today's class, we can study ideal gas molecules. So now what are ideal gas molecules? Do you know?
No.
Ideal gas molecules are basically the ones that follow the gas law. So you have a gas law, which is PV is equals to nRT. So what happens is, just give me a minute. I'm opening your specification. It's not opening. Just 1 second. Okay, everyone. So please look on the screen now. In ideal gas molecules, first of all, is my screen visible?
Yes.
We studied about the random motion of gas particles. You remember? So what is
Yeah.
the random motion?
They move 500 meters per second.
Exactly. The particles of gas are always randomly moving and they collide with the walls of the container. That creates a right. Now, what is the meaning of absolute zero?
273.15 degrees.
Exactly. The lowest temperature that is possible is, for example, minus 273 degrees Celsius. Okay, where particle motion stops.
That equals 0 Kelvin.
Yeah, or you can say 0 Kelvin. In degree Celsius, it is this much. In Kelvins, it is this much.
So, ma'am, what is the highest temperature?
Highest temperature is infinite. It can go up till anywhere. Like the lava has 4,000 degrees Celsius temperature.
Oh, okay.
The particles, motion, stop. Okay, at absolute zero temperature. Then what happened? You should know how to convert. So degree Kelvin, Kelvin is equals to degree Celsius plus 273. Okay,
Okay.
directly measures average kinetic energy of particles. Okay, it is going to directly measure the average kinetic energy of the particles. Now, what about temperature and speed?
What, ma'am?
The temperature and speed. So we know higher is the temperature, higher average speed of gas molecules. Okay. So higher temperature means higher average speed of the gas particles. Then we have the gas laws.
Do I write all of this down?
No, don't write it down. I will provide you the screenshots. Don't worry. Or first understand, then I'll give you time. So what are the gas laws? So gas law is basically that pressure, volume at constant temperature. Now, what does it mean is basically when temperature is constant, we are defining the pressure volume relationship. So when pressure is constant, when temperature is constant, the pressure is inversely proportional to volume. That means high pressure, low volume, right? Low pressure, high volume. So we can also write it as P1 V1 is equals to P2 V2. Understood?
I did not understand.
See, whenever you have a fixed amount of temperature, whenever you have fixed amount of temperature, the pressure and volume are inversely proportional to one another.
Please repeat.
Whenever you've got fixed temperature, the temperature is fixed. So the pressure and volume are inversely proportional to each other. They are inverse. For example, if you've got fixed temperature, the temperature is fixed. So higher the pressure, lesser will be the volume. Okay.
Oh,
So
okay.
pressure and volume are in inverse relation, right? So that is why P1 V1 is equals to P2 V2. P1 V1 is before, while P2 V2 is after. Understood?
Ma'am, but when do we use this formula?
Then I'll just provide you some questions where you will understand better. Okay.
Okay.
So this is the first gas law. What is the second gas law? It is pressure temperature relationship. So what is the pressure temperature relation? So when volume is constant, the pressure is directly proportional to temperature. That means higher pressure, higher the temperature, and lower pressure, lower the temperature. So there are two laws. When temperature is constant, so pressure and volume relationship you will find. When when volume is constant, pressure and temperature relationship you will find. And when temperature is constant, pressure and volume relationship you will find. Okay?
Okay, so now I have a question.
Yes.
If the temperature stays the same,
Yeah,
the higher the pressure, the lower the volume.
exactly.
And if the volume is the same,
Yeah.
then the higher the pressure, the higher the temperature.
Yeah, exactly. So for this, you can have this formula. P1 upon T1 is equals to P2 upon T. Okay. So now, just do one thing. Now you can note down. Okay. I'll just keep scrolling and please keep noting down the points, right?
Okay. Ma'am, scroll down. Ma'am, can you go a bit higher? No, ma'am. Higher, higher. Little bit more. And we can scroll down. Ma'am, I have a question.
Yes, Yvonne, tell me what's your question.
Pressure equals force over area. Temperature is not in the equation, so why is temperature here?
No, we do not use that formula for that. We actually have a gas law that's P V is equals to RT. But this is not there in your syllabus. So according to this formula, we relate everything. Pressure, volume, R is again a constant and T is the temperature. So we are relating it with another formula, okay? Not P is equals to the force one, we are not using that formula, right?
Oh, okay. Ma'am, can you go down? I'm done.
Yes, completed. So 1 second now. Now I'll just note down a few more points. Till here, do you have any doubts?
No.
Yes. So Vivan, now we have heat energy. What happens is understand the first one. The heat energy, what it does, it raises the temperature or it changes the state, but it does not do both at once. So either it is changing the state or it is raising the temperature, but it is not doing both the things at once. Okay. Then what is the specific heat capacity? Specific heat capacity is telling us the specific heat capacity is telling us basically how much energy is needed to heat a substance. What is the Kelvin temperature? Kelvin temperature always represents the energy of a moving gas molecule. Then what is the gas pressure? Gas pressure is depending upon the particle collisions, changing volume or temperature changes in the pressure. Right? So these are some of the important points from your lesson. Please note them down as well.
Ma'am,
Yes.
there's specific heat capacity, like how quick, um, like 1 kilogram of substance can change temperature
No, it's not how quick. How much energy do you need to change its temperature?
by 1 degree Fahrenheit.
Yeah.
Is it Fahrenheit or Celsius?
Please, can you repeat again?
Specific heat capacity is the heat energy needed to increase the temperature of 1 kilogram of substance, yes?
Yeah, by 1 kilogram of substance by 1 degree Celsius.
Okay.
Please note these points.
Ma'am, can you go down? Ma'am, I don't understand points 3 and 4.
Okay. So point 3 says, what does the Kelvin temperature represents? Kelvin temperature is actually representing how much energy the moving gas molecule has. Okay, so it represents the energy of the moving gas molecule, right? And what is the gas pressure? The gas pressure depends on the particle collision. Means how much are the particles colliding, the change in volume, or the temperature changes and the pressure. All of these things are represented by the gas pressure. Okay.
But what does temperature changes pressure?
Temperature changes, yeah, it does, right? So we studied this pressure and temperature relationship. So that's how temperature and pressure are interchangeable.
Oh, okay.
Yeah. Did you note everything now?
Yeah.
Okay. Now,
But ma'am, I still don't understand point 3.
point 3 is, see, we already had the degree Celsius scale. So what was the necessary for, what was the need for Kelvin temperature? So the need for Kelvin temperature is basically, it represents the energy of the moving gas molecules. In higher classes, whenever you are solving the questions, you will understand it better that the Kelvin temperature you are using whenever you're dealing with the energy of the gas molecule. Okay.
Okay.
Okay. Now I will provide. Have you noted this thing down?
Yes.
Please just give me a minute. I'll just put my device on charging. Then by the time I'm writing some questions, just do them. Okay. Just give me a minute, please. Yes, Vivaan. So let's come to the questions.
Okay.
To this question. Everyone will do these three questions.
Ma'am, which questions?
Is my screen not visible?
No.
I was writing on the screen. Okay, 1 second. Is it visible now?
Yeah, now I can see it.
Okay, please do these three questions.
I'm done. Ma'am, I'm done.
Okay, let's discuss the answer. Tell me the first answer.
300.15 Kelvin.
How did you do it?
I did 273.15 plus 27.
So 0.15, 300.5 Kelvin. That's correct. Answer number 2.
The bigger the gas, the lower the pressure, and the lower the gas, like the smaller the gas, the higher the pressure.
Volume and pressure.
Yeah.
What is the volume?
The higher the volume, the lower the pressure, and the lower the volume, the higher the pressure.
Okay, correct. Next. This is pressure is given, volume is given. So this is P1, this is V1. Okay, volume V2 is given. You have to find P2.
200 kilopascals.
With which formula?
P1 over T1.
No, P1, V1. So 1000 into what? 100, sorry, into 2, P2 into what is V2? 1 liters. Okay. So 200 is P2. Got it?
Okay.
Okay. Now come to the next set of questions. Copy the question also, okay? Okay, you have to calculate energy and I will give you the formula also. Do this question.
I'm done. Ma'am, I'm done.
Yeah. So, okay, tell me the solution. You get mass is 2 kg,
4,000 joules.
4,000 joules. Okay. So mass is 2 kgs into. What is C? 900. Delta
Yes.
T is 30.
3
Okay. 18 into 54,000.
joules.
Okay.